All right, so here we have a patient on a brown rice and skim milk diet is required to have at least 800 calories and at least 32 grams of protein per day. Now, each serving of brown rice contains 200 calories and 5 grams of protein, and how many servings of each food should be eaten per day to meet the minimum daily requirements? All right, so again, we're going to have to set our variables. So in this case, we're going to say X is the number of daily servings of brown rice, and Y is going to be our number of daily servings of skim milk. Okay. And so we plug in our problems and we arrange information. And so we said brown rice is going to be 200 calories per serving, skim milk is going to be 80 calories per serving, and 5 and 8 grams of protein respectively. And we had to have 800 calories for this and 32 grams for this. So what does our calorie requirement show? Well, 200 times x plus 80 times y has to be greater than or equal to the 800. And down here, we have 5 times x plus 8 times y has to be greater than or equal to 32 grams of the thing for daily requirement. So now we've got these two things, and both have to be non-negative. So we have our x and y have to be greater than or equal to 0 again, okay? So those are going to be pretty much a lot of these problems we're going to, application problems, those are going to be in here. So when we graph these, we're going to graph both of those, and we'll have our blue line and our red line. And again, they're going to be solid because of the fact that we have that greater than or equal to. And we know that it's going to be in the region in the first quadrant. And so what happens is our solution region is only going to be kind of like from here down to here, over to here, and everything that direction. Okay. And so again, we can use our calculator to find our intersection points. And when we do that, that's what we see. So that's going to be our solution region, everything in that region. So the 6.4 here, 3.2 comma 2 here, and 0, 10 here. That is going to be our corner points, and everything else to the right and above is going to be our shaded region. Okay. So anything in that region is going to actually satisfy our minimum daily requirements for both calories as well as our protein. And so that's how we're going to solve our problems. We first, a lot of times we have to come up with our own equations or inequalities in this case. We have our constraints, our x and y have to be greater than or equal to 0. After we graph them, then we get our solution region. And we always have to find our corner points on these to make sure we know where those are. All right. Anything outside of that region, basically, though, don't satisfy this. So anything over here or down below or up here, those don't satisfy. And so those are going to be outside of the region and they won't satisfy our solution. All right. I guess, yeah, one last thing. This is kind of like example one. It's going out this direction, so it's unbounded. And so that's kind of a key thing. Sometimes they'll ask you, is this solution bounded or unbounded? And so you have to know that in this case, it's going to be everything going this direction, so it's unbounded. Now, what if we had said instead, it ends up being this region down here? If that one, well, that case, if that was the actual solution, then it would be a bounded solution. Okay, so again, difference between unbounded going all the way and bounded where it's kind of set in a circle here or a shape where it's bounded on all sides, and that's going to be our solution. All right, so that's all I have for this section. I'll come back for more with section 3.